and welcome into yet another live stream, and I am better. I'm feeling better. Continue stream the second I decided to go to sleep. I'm sorry, Mark, I'm sorry. I don't make the rules, I just enforce them violently. Anyway, hi there everyone, I am feeling better. Which means, you know what that means? It means we're gonna have a productive day today. Oh boy. Oh boy, oh boy, oh boy. Oh, let me make sure everything is in place. There we go. There we go, and there we go. Glad you're better. Thank you, thank you. Well, kind of better. No, better doesn't mean best. I am still feeling a bit under the weather, and the stress from the whole thing has given me a bit of a headache, but it's fine. I'll take it. I'll take any wins I can get. It's a win. It's a win. I count as a win. I haven't really. Oh no. I have some coffee here, but I'm scared to drink it. Procrastination, please. No more procrastination today. We're gonna be doing elementary particles. Hi, the Reblax. Atomic. My goodness, I've just started. Alrighty then. Welcome back. Well, glad to be back. Oh, I haven't been streaming in such a long time, you know. It feels like just yesterday we streamed a charity checkup 20. Alright, there we go. I started because my brain started thinking about dates. And there we go. So, the American. Don't drink and it will hurt your stomach more. I know it will, but it's a trade-off, Happy. Everything in life is a trade-off. You gotta pay the price. Oh, also, I haven't got any milk. I have to go and buy some. I wanted to go to the shops yesterday, but I couldn't because of the whole, you know, feeling like shit debacle. So I don't have any milk. I have to just drink it black. Ew. What do you mean productive day? It's 1 AM for you. That's still a day? Actually, it has to be 1 AM because if I streamed an hour ago, that would be 2 streams in a day. Can't have that. Morning, well, having general. Yeah, fine morning indeed. What kind of ritual will we do on day 666? I thought we could just... I actually don't know. I'll be honest, I am a bit of in the middle of something, which means the streams soon enough might start being a bit more... There might be a period, around a week long, next month, where basically the streams will be really short. That's because I'll be doing something. You'll see soon. Guys, drinking coffee, is that bad? Depends. When you're drinking, how old are you, a lot of things. Listen to Comedy Bro while playing Doom Eternal. I'll just play Doom Eternal. I'm pretty good with Doom Eternal, or at least used to be. Walking the company. Yeah, for the company. Make it as Mr. Beast. Well, kind of, you know. I'm a bit more popular, but, you know, no need to point any fingers, you know. No need to compare, I would say. You know, who's more famous? I feel like that's a bit pointless. VLC Media Player, there we go, and let's play the music. Mr. Beast and kind of an insult. Is it? What happened? I'm not, I don't know the drama, I don't know the YouTube stuffs. I really don't. I am too focused on American politics to notice the drama. Are you happy with Doom Dark Ages? Yes, I am! My goodness, I've been waiting for such a long time for a sequel. Rather fun doing one. Mr. Beast got exposed. For what? Are the fundamental elementary particles the same? Yes, I'm pretty certain. Well, they're called elementary particles. It's fundamental forces, the way I've seen it so far. It is elementary particles. Although some of them are gluons, which are just fundamental forces. So... Dogpack 404, if you want to know what happened. Can't you give me like a short summary? Because I'll be honest, Reblax, I don't fancy looking it up. He fakes videos, treated some people that appeared them very badly. Would be a war crime. Huh. Waiting on the next Doom for ages. Yeah, and those ages have been pre-done. Oh, that's so funny. Exploring minds promoting gambling. Well, I mean, you know, exploiting miners, you know, the coal isn't gonna mine itself, right? They're smaller, they can fit in shafts, right? They can mine it better. So I'm just saying, I get it. That's all I'm saying, okay? What, you're supposed to have you adults mine diamonds? Okay? Like, come on, you know how big the tunnel has to be for an adult to get through it? That's ridiculous. But stuff's nice stuff following drama. Keep playing Minecraft, the children need them. The thing is, I don't like drama because it's most of the time drama is just like two people engaging in like a performance argument for money. Cancel make it. I am uncancelable. I don't know what I would have to do. The thing is, I would have to do something that's illegal for me. Like, the threshold is so far for me that I would have to do something illegal and go to prison before I become cancelled. Grand scheme of things, how big is this game to be? Nothing is important in the grand scheme of things. That's called nihilism, Spoon. Physics makes you essentially depressed. Maybe you. Physics makes me feel great. You know how much energy you have in stars and black holes? And like energy that isn't ruined by entropy. Just energy you can get out of them. Physics makes me feel amazing because we have so much power in our solar system. There's untapped power waiting to be tapped. Just started doing calculus and they already have me doing trigonometry help. Trigonometry's not that bad, is it? Is it? Make a how math gets difficult type video without basically copying a video, but it's very here. That's kind of the problem. That's why I don't watch videos about different topics when researching for my videos. That's why I mostly use Wikipedia, LibreText and random books, because it gets tricky. It's really easy to plagiarize on accident. What do you mean no child labor? The children, yeah, for the mind. Exactly. And flame, exactly. We can't forget about flame. I do exploit flame. Just dress up as an SS officer and go to Germany. You get answered pretty quick. Okay, yeah, you know what? Actually, yeah, that might do it. Actually, Sesos. You know what? That actually would do it. I take that back. There is a way for me to get cancelled before going to jail. Although that's what's so interesting, actually. You know what's that's what I find so interesting. I know I'm going off on a tangent, but I feel like it's really funny. It's a prime example of the difference between Europe and America when it comes to freedom of speech, for example. So in America, all speech is free. In Europe, it's not, but the things that aren't free are like, I don't know, denying the Holocaust. So for example, if I tried denying the Holocaust, I could end up in jail. That's it in Germany, unfortunately, only. And in Poland, it's not a thing yet. Yeah. New micro movie trailer has the yearning for the minds. Oh, when he said I'm Steve, I just lost it. I couldn't anymore. Oh, I lost my marbles. It was incredible. I cried. I cried. I'm not afraid. I'm not ashamed to admit that. I looked away for like a minute. Well, you shouldn't. No, make his live stream. I'll make his live stream. Anything is possible. It's called Elementary Particles. Fun fact, this is a video I've been wanting to make for how many months now? 3 or 4? Quarks. There we go. Yeah, I'm right away gonna start animating stuff because I wanna mostly have free speech, but Supreme Court said many exceptions for that. Well, I mean, yeah, there are the obvious ones. Like, you don't want speech that leads to death. Like, speech has consequences. But still, it's way broader than not free, even the armed freedom that is the US. Hi, the deep guy. Should I do Italian for dinner? Well, if you want to do an Italian for dinner, I don't know. I guess taking him out to dinner is a nice gesture. Boy, that was I'm proud of that one. I stand by that pun. Being an American in 2024 kind of cringe for real. I agree. Can you imagine being American? Can you imagine being American? Am I right? Americans. Deny the Holocaust deniers. I'm pretty certain J-Rage made a video about the flat earth deniers. As an American can confirm, very cringe. No, my internet! Ah! Go up, go up, go up! Kilobytes per second, go up, go up, go up. There we go, we're back. Supreme Court just sounds like what politicians need to help for their money. Not really court doesn't help the people. Whoa, are we redoing a politics live stream? I want to say hi before I leave. Can you give us some insight about Polish food? It's meat, potatoes, salad. Kind of it. Review what climate change denialism. Yeah, I love that video. Wait for transformation. It will good again. It will good is such a... I love that phrase. It certainly will. It sure will. I always thought Make It was Italian. Because of the accent? I have a mess of an accent, that's probably why. It's hard to trace. Bye, deep guy. Bye, have a good one. Happy doesn't know anything is absolutely wrong in anything it says. Aren't we all, though? Because I'm such a sick and twisted guy. Like, I'm actually like Joker from the movie Joker. Okay, the thing is, I've always found J-Rish funny, but J-Rish did something which earned a lifelong, like, respect from me. Was it capital of Canada? I think it was capital. Canada, hold on first. First, let me look up Canada. Was the... Toronto. Wait, no, that wasn't Toronto, was it? Was it Toronto? I don't remember. Ottawa, thank you so much. Right. Election 20... When was it? 21... Ottawa was great. Was it not 22? 22, there we go, municipal election. It was absolutely phenomenal. This and my lifelong respect. Ottawa, right here. the paragraph is amazing. Gregory J. Rage Guerreva, 25, is a YouTuber and journalist who goes under the synonym Dreg online. He writes for Capital Current, formerly The Charlatan, The Apartment 6313. Guerreva denied that his campaign is a joke instead of referring to it as a post-ironic. He stated that he's simultaneously a libertarian and a socialist and described his political beliefs as anti-centrist. That's such a J. Rage. Oh, it's incredible. Always streaming at like 7 or 8 o'clock in China. It's on the only time I had time to stream. Supreme Court can be good, but current era largely seems focused on implementing agenda around implementing government. The Supreme Court can be good, yes. Well, the Supreme Court has been criticized recently. Oh, are we already doing a politics live stream? No, that's not a good idea, is it? Enumclaw horse. Oh no. I sure do like doing an Enumclaw. Oh. I know how much of a Enumclaw horse scandal can I say before we're getting into the problematic bit. The bit of a horse, you know, in that person. Now, yeah, so the Jerez is amazing. I'm actually identified as anti-life. I believe all women should have abortions always. Actually, I also have a pretty strong stand on abortion. Well, kind of a strong stance. You see, it's a problematic issue in my opinion. Abortion is certainly a problematic issue and people of good faith can disagree. That's because, like, I myself, I don't think it's controversial. I like the idea of killing children, but I don't like the idea of women having more rights, you know? So it's a complicated issue, certainly. Another donation. Master Mass. Bye, Atomic, bye. Have a good one. Good luck. There we go. I'm just gonna extend it. In 5. Is a British murder make it? Depends how you define murder. I'm not that kind of god. can't define murder for you. What I can say though is that's kind of how annoying this all gets with politics. Is because you always need some sort of underlying assumptions, right? But you always need some sort of underlying assumptions, but people really often disagree on different topics without realizing that their underlying assumptions are just different. Okay, God, simply reminding us he is a god. Yeah, listen, remember, it's only a god complex if you're not a god. Murder is the killing of a human life, then yes, it's murder, but it's not the killing of conscious human beings, it's not murder. Yeah, but that's the problem there, Spoon, is that that's not the objective definition, is it? Knowingly killing of another person. But that's another issue, because then you need to define the person. Like, the thing is, there is nothing wrong with playing God if you do it right. Holy fuck, that goes so hard. Oh my goodness, that's... I'm gonna save that quote. That's a good quote. The thing is, the problem is that it's really difficult actually to make even a definition for murder. And that's because that kind of blurs the line between what is human and not. You can't remember how many people should they be charged with. The thing is, with murder we usually get away with because it's easy to define death. It's pretty easy. That's because we have medicine to define death. You know, we have stages of death, so on and so forth. Actually, as science advances, the less stages of death actually become stages of death. I don't know if that makes sense. So basically, the more advanced equipment we have, the further in the process of death can we reverse it, which is incredible. I think as with long hair in the live broadcast, are you the host? I am. Yes, it's me. Make it. I am a host. Yes, I am. I have kind of, I don't know, long hair. If you kill a pregnant woman, how many people should they be charged with? I don't know. I think, I don't know. Can't we just do like a murder, like you know, like a trial for murder? Can't we just listen? Call me crazy, but I think if you kill a pregnant woman, the actual, you know, amount of people you've killed isn't quite as significant as the murder bit. The kind of unjustified killing. Yeah, that runs into a whole other problem of what you consider justified. But putting that aside, the human's body be complex. My position is pretty simple. You can make an argument for both sides. You can make an argument. It's important to know what their KD is. My position is pretty simple. Both sides have a valid argument, and so because of that, it shouldn't be decided on a matter of ideology. You're still killing someone. Yeah, I mean, yeah, that sadly seems like kind of terrifying. We are destroying potential consciously. The question then becomes, what is the nature of potential that is a kid? Well, the thing is, it's all arbitrary about lines. That's the thing that frustrates me in politics. But the issue, red flags, I have with politics is that on one side, like on one hand, yes, it's incredibly annoying because most of politics is just beliefs. And people arguing over beliefs is possibly one of the top 10 dumbest things in existence. I agree there. However, when it comes to politics, there is also a lot of things which are scientific and not based on beliefs. You see, when you have some sort of policy, when we have different policies, there are different ways to argue for them. So for example, let's say we have murder, right? You have a person just throwing a knife. There, that's a knife, don't worry, it's a really thin knife. At another person, right? Like that's, at very least, attempted murder. And you can make two cases for it. First one being that murder is bad. That's your first case. Pretty common in politics, so just saying something's bad, and that's valid, I would say. I would say that's valid. You believe murder is bad, that's fine. However, you can then make another case where you basically do a study, and you're like, okay, if we make murder legal, then our society will become a lot more unstable, we'll have a lot of people dying, which isn't great, and therefore murder should be illegal. It's not attempted murder, Your Honor, it's amateur surgery. And so the thing is, it's really important to distinguish between the two. Because the first one, you cannot argue over the first one. You cannot. It's a matter of belief. You cannot argue beliefs because beliefs, well, we believe in them. You always need some underlying belief, so you can't argue this. You can argue the second one, however, and even more important, you should argue the second one. So that's why I really want politics, this kind of politics, to be mainstream. I want people to be interested in politics simply because there are a lot of ways in which political discourse could be scientific, and that would be phenomenal. Can you imagine? Oh my goodness. Can you imagine a society in which political discourse would be just mostly scientific and us arguing over the effects of different policies? Like, how great would that be? This one is politics, and it says the large anti-intellectual movement which causes people to entirely base their arguments on beliefs. I mean, the pickle there is, yeah, I mean, okay, I'll be honest, I'm not the biggest fan of the whole just denial movement where people just stop trusting any source. That's not fun. As a scientist, I'm not the biggest fan of people just not trusting sources, because, like, research is kind of important. I can remember, but the problem is that philosophically speaking, I don't care about society becoming stable. Yeah, but the thing is, we humans are incredibly lucky because most of our beliefs as a species are the same. The absolute most. Considering the range of every single possible belief, human beliefs are a tiny fraction. Human beliefs that all humans hold are a tiny fraction, and we yet all still have them. Which means that, you know, abortion is controversial, but murder isn't. Everyone doesn't like murder for no reason. Now, the reasons there are a bit more of a pickle, but everyone doesn't like murder for no reason. If you imagine a person, a blank slate, a person who you know nothing about, you don't want them to die. Right? Like, that's something that's, you know, pretty human. You don't want that person to die. Evolution kind of put that in us because, you know, otherwise we would be killing each other way often and, you know, it would be problematic. And the thing is, when we establish these absolutely obvious, and I do mean absolutely obvious, nothing controversial, completely obvious things, then, yeah, it's actually pretty easy. We disagree with that, unfortunately, make it. No one would disagree that murder for no reason is good. No one. Unless you're talking about, like, I don't know, psychopaths or serial murderers, but, you know, there's always gonna be, I don't know, 100 people out of 100 million, but I don't think we should focus on the 100 people out of 100 million, because, well, the obvious things are obvious, they're not things we are talking about. Yeah, but we can start there. So we can start there, and then we can take each policy and just analyze how it will affect these extremely obvious things. And that is important. So, for example, and there are another thing, really often you also have legislation which claims to be implemented with a certain goal, right? So if you have some sort of piece of, like, for example, making alcohol illegal, all right? Let's do that. Making alcohol illegal, that being that kind of legislation being put in place for the sake of keeping people sober and keeping productivity up. Okay, someone is trying, let's say that we're living in, I think, 19th century, or I think 19th century America, or 20th century, I don't remember which one was it exactly, 19th or 20th century America, and let's say we want to outlaw alcohol because it makes people unmotivated. It's a big problem. Well, then the thing is, we can just do some research, some testing, and we can see that if you outlaw alcohol, what's actually going to happen is people will just get it illegally. And then that leads to all sorts of problems, like kids drinking, or, you know, people just basically lose all the regulatory power over it. And then you can see that the ultimate goal of, from productivity to keeping crime down, all these things just won't be fulfilled. Shaky, like, you can't do scientific methods on countries, study them like particles. You actively anti-science, don't care about analysis. Yeah, but that's the problem. The thing is, it's not that you can't do scientific method on countries, it's that it's difficult. And that's true, it is difficult. It is certainly difficult research with, you know, obviously pretty important difficult research. However, I don't think just because it's difficult, we should give up trying. Like, if our two options are basing politics on ideologies, or doing research, the drawback of research being that it's difficult, I still feel like we should do research, right? Okay, it's difficult, but I mean, I'm paying my taxes. Use it for research. I like science. I suppose that's my ideology. I guess that's my belief spilling over. I just want my taxes to pay for research instead of, I don't know, getting sent to America just to buy weapons. Hey, did I mention that I pay a lot of tax to America? It's fun. Hold some questionable view on science-related issues. That is... I have seen in Discord, yeah, homeopathy you mentioned, I do believe. You're French, right, Roblox? Just answer the question, is there objective morality? No, there is no objective morality. Feeling better today? I am feeling better. I mean, kind of. My stomach still hurts, but it's much better than yesterday. Every now and then I get the chills, but you know, it's fine. I'm not dying, probably. I don't want to get into a whole conundrum. The thing is, though... Well, France is politically... It's an extremely interesting country. I do believe that political situation in France is more interesting than America. In America, it's funnier. Definitely more funny. But French situation is way more interesting because you basically have... Your government is so divided. Left, center, that no one likes, and then right. And so you have people who love the right, you have people who like the left, you have people who are in the center, but simply because they don't want left or right. More than two parties to actually rise up and something like this. Yeah, that's what I'm saying. That's why it's more interesting. That's what I really like about Europe, having multiple parties. I always use the European Parliament as an example. Murder is objectively wrong for our society. Yeah, if you argue murder is objectively wrong, it's not objectively wrong as in the grand scheme of things. I'm saying that we as a human species evolved with a certain set of values. Values which we have simply because our species would have a much harder time surviving if we didn't have them. And because of that, on a genetic level, we have certain things which we all consider good. Simply good, with no explanation for it, we just all believe that. So we can say that murder is bad. It is subjectively bad, but if it's subjectively bad for all humans, then you know, it's not really a problem. That also comes with an asterisk, of course, because murder, that's unjustified killing. However, justified killing is a pickle in its own right. Oh, this problem. Oh, you mean the orthogonality thesis? Is that what you mean? That's an AGI thing, which... Existential risk from artificial intelligence! How have I never seen this site? That's amazing, I absolutely love it. Yeah, there is orthogonality thesis, which basically stems from the odd is. Can't derive something is right or wrong from logic alone. Yeah! This is where this came from, so basically any level of intelligence compatible with any goal. That's because no goal is objectively right or wrong. Hello. Alright, still press bye, see ya. Would you prefer eternity of suffering going to nothing? Going to nothing, definitely. Why would I suffer for eternity? That doesn't sound like a good time. Hi, there's someone random. Welcome. But yeah, basically the thing is, I do believe that as a science community, we should try to make everything as scientific as possible. As I mentioned, I won't hide it. That's because I won't hide it. I'm a science cultist, okay? I believe that science has answers to everything. I'm a science cultist. I won't deny that. I am biased. However, I still believe that we should try to scientify everything, and that includes politics. What really pisses me off is when really often people try to make claims based on beliefs and back them up with science. There's nothing wrong with a claim based on a belief. There's absolutely nothing wrong. What pisses me off is when people try to hide it. Because that's basically doing bad science. What is everything? Well, everything, I'm assuming. Wouldn't you get numb to suffering after a while, but nothing is just nothing? Well, not quite. You can't get numb to all suffering. There are limits. You could go insane, but I don't know if, depending on the kind of suffering, that insanity wouldn't stop you from still being tortured. It would still suck, exactly. The thing is, if I had to choose between an eternity of pain or killing myself, I would kill myself. However, one of the biggest reasons actually why I am so anti-suicide is because I do believe that people who want to commit suicide see this as a simple trade, as an eternity of suffering or ending it all. However, what they always seem to fail to consider is that it's not eternity of suffering. Things always get better. It's a trend. If for nothing else, simply because of technological advancement, things get better. There is always hope. And I really feel like people should account for hope more often. But that's just a side thing. Eternity wouldn't suck if we just forgot what happened for like 1,000 years. Or eternity wouldn't suck in general. The thing is, we really often like to pretend that we get bored, but we get bored in very specific situations. Imagine you have an infinite amount of money. After how long would you get bored? I don't think there is a point at which you would get bored. Honestly. I really don't. That's because we really often limit ourselves down to the most simple experience. Like, yeah, living in luxury can get boring, but that's simply if you really live the whole day over and over in luxury. It's comfy, but it does get boring. However, you don't have to just do that. You're not confined to anything. That's why I like kind of the idea of, you know, living for eternity. As long as I'm not getting tortured. If I'm being tortured, I'm gonna give it a pass. Visitor makes... Okay, we could do introduction, actually. And also my task got broke again. Festive. Wait, did we just do a philosophy? No. Oh, damn it. Did we just... No. No, that's not philosophy. That's science. Everything will go black eventually. You mean the heat of the universe? That's so far in the future. Unless you mean like... Everything go black, there would be no energy, I would just be stuck suffocating myself, but yeah, I wouldn't want that. Physical theory of the universe. It's not everything. Complete physical theory wouldn't help us with the thing we understand under politics. Complete physical theory would help us with the thing we understand under politics. Very much would. Our brains aren't magic. We could simulate a human brain if we knew how. The thing is, if we if we had the technology required, we could just get a bunch of politicians in a room, scan all of their brains, and figure out basically and simulate which policy sucks the least. We could. It's not impossible. Our brains aren't magic, as I mentioned. Actually, no, let's not do this. Let's do... Oh, I have a lovely ice cube model I made a while back. If you're a mortal, it would be like you saying Monday is so far away. Yeah, that's what I'm saying. If you know, if I wouldn't die during the heat of the universe, I wouldn't want that. Simply because, well, that's an eternity of torture again. Living for an eternity at the heat of the universe, that's torture. That's the torture forever. That's wrong, not this one, on the... Was chemistry one correct? Immortality sucks. No, it doesn't. Feeling bad sucks. If you feel bad for an eternity, that sucks too, but immortality by itself doesn't. Oh, I forgot to switch to cycles on the GPU. There we go. Look at that ice texture, my goodness, I am so amazing. Don't have theories, not the computational power. Yeah, we don't. We don't even have a theory of everything. We have 3 incredibly accurate theories and no way to merge them together. What if a big crunch theory is right after so many years you can see the rebirth of everything? which is a long time. I am curious, because the thing is, we like to really often pretend as if we know what happened at the beginning of the universe, or what's gonna happen at the end, but we have no idea. When it comes to, in mathematical terms, you could basically say that you cannot get the derivative based on a single point, or the second derivative based on 2 points. Basically, the more you want to talk about change, the more data you need. And like, yeah, we as humans have lived for quite a while, but as an advanced society, the universe has been practically stationary throughout our entire life. So it's really difficult to say how the universe changes in a grand scale. We'd need to live for at least trillions more years to actually... Well, actually no, we'd need to live for like 1,000 probably, because of how exponential the growth is, but we need to go for like 1 trillion years to actually be certain. Can I set the color to be extremely high number? I can. Oh, this is amazing. I love it. Oh, this is so funny. This isn't glowing. This is just reflecting light twice as much. That's great. Do you ever feel like you are missing out on life? No, simply because I have a plan. This is just one step. I don't want to promote being antisocial or, you know, sacrificing everything. I want to make this clear. This is a temporary state for me. Like this state of, you know, just walking myself to death. I don't want to promote people to just, you know, I don't promote like a bad lifestyle. Cooking with math is that you don't get the existential fears about stuff like heat of the universe, just existential fears about the very nature of thinking itself. I feel like if you're getting existential fears from doing physics, then you're doing physics incorrectly. That would be my hot take. Because all of the existential dangerous things, those are all hypothetical. The only practical ones we know are the ones that actually aren't that bad. They're pretty good, actually. So for example, as I mentioned already, energy of stars. It's incredible how much energy there is in stars. And if we could harness that energy, that would be great for us as a species. Why does my taskbar keep breaking? Windows. Getting too much out of life. My antisocial gives me the ability to just observe the reality around me. I don't think that's your antisocial, Happy. Being antisocial is nothing but a thorn in the backside. Being antisocial is not like a plus. If you can observe if you can observe the reality around you, that's separate from being antisocial. Heat of the universe by climate change or something. Okay, climate change is a bit more difficult. That's fair. Yes, climate change, nuclear war, and AGI. Those 3 things are basically like end of the world scenarios, with, you know, climate change being the tamest but at the same time most probable since it's already here, nuclear war being worse but less probable, and AGI being quite unlikely simply because we're not there yet, and if we're careful we could just avoid it. However, the worst one. So Spoon, I'm pretty certain you're describing absolutism. Or positive nihilism, whatever you want to call it. Okay, we want the background. We want a nice and chill background, like a noise texture right here. Block it off as much as possible. Okay. Most of the air represents measures making jobless fun. No, I think word. How would I? I don't want it to just be white. Maybe I do want it to just be white. Actually, why not? White not, I could just plug this in as a base. This one is exponent like power 4. Then I could do multiply by 10. And a fair warning, powers usually crash my computer. So if I set it to 8 right now, if the stream ends all of a sudden, my PC crashed. Okay, never mind. We're good. We're fine. Cool, no problem. There we go. Yeah, that's a cool background, isn't it? Oh, we might need to record this, right? We might need to record it before. When you far into it, you'll see vaguely cloudy blobs arranged in a neat pattern. If we zoom in, ice cube. If you zoom in, far into it, you'll see vaguely cloudy blobs arranged in a neat pattern. Oh, this is going to be a long animation. And also, I would like the background to be a bit brighter, like 20. Okay, that's maybe 25. Not 50 to 25. I like it. I like it. Maybe a bit more detail would go. There we go. Green background. No, I feel like we can go with pure white this time. Actually, might be it. I don't know. I know what else to do. I can increase the brightness of the floor. What would be the difference between it glowing and... I like this more. So basically extremely reflective. Roughness doesn't even matter at this point. Okay, there we go. That's nice. And then what we'll need is like an extremely long animation, simply because I don't know how long the intro is gonna be. Let's start with an ice cube. Let's start with an ice cube. If you zoom in really far into it, you'll see vaguely... Okay, so like 6 seconds, which means 6 times 30. 180 plus... How much? You see vaguely cloudy blobs arranged in a neat pattern. So 4, I would say. Which means 10, 11, let's do 11 just to be safe. And then 200 and... just 200. That's where we'll start moving. Why did it change? Oh, damn it, I didn't... Oh my goodness, you're unbelievable. Are you mixing it? Just piss off. You too. And you free. And you piss off. There we go. Neat. Kinda looks like an ice cube. Oh my god. Oh, it really does. Okay. So right here is where we're gonna start our animation. And then we're going to go into the ice cube. Alright, now we're going to add depth of field, like 2. And then we're gonna go even more in depth. Difference being, we're gonna start at 0, 1. There we go. Uh-oh. 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 We're back. Never mind. I don't know. I'm an idiot. Don't worry. I like it. I do like it. And now one last thing, which is we want the background to change. I feel like that's subtle enough. There we go. There we go. Oh my goodness. Okay, I just had a math thought. Wow, I just have a math. That's such a nerdy math thought. What? Here's the thing. I have two keyframes. Okay, Reblax, I think you might appreciate it. I just had a math thought. So basically, there are two keyframes, right? And I just switched their interpolation from Bezier to linear. What that means basically is that if we imagine these two keyframes being values of W, this would be Bezier basically. Kind of. Or maybe this. The point is it would be like smooth. And then this would be linear. Just straight line. And I was thinking that the animation was going really quickly because I was looking at this. So let's call this f of x, let's call this g of x. And I was thinking that the animation was going really quickly because it would be basically equivalent to the derivative. And I was wondering if it would be... No, wait, I messed up. I did mess it up. It starts slower and then starts speeding up. Oh, Bezier. I could actually take a look at the graph drivers, I suppose. We'll write this one, default value. Of course, it's very subtle. If I switch it to Bezier, what's it gonna look like? Flat and flat. Should have seen that coming. So basically, it will be flat, and it will go up. There we go. So in the middle. Now, I was thinking that was changing really quickly. So the change would be basically equivalent to a derivative, of course. So I thought for a second that it was changing really quickly, but was it due to animation being really quick, or was it due to the shape of the curve? And so basically, I thought, okay, is the derivative of the function greater in the Bezier, or is it greater in the linear? My intuitive thought was that it was greater in the linear. Oh, did I get that right? I hope I did. My original thought was that it was greater in the linear. Greater in the Bezier, I mean. Because right here the derivative is smaller. And so, basically, if derivative is originally smaller, it has to be greater in the middle to reach the same value. Ah, did I get that right? So that would be the... So basically, no, the area would not be the same. Rediscovering the mean value theorem. Am I now? I'm thinking how to quantize it, exactly. Not quantize, I'm not... Damn it, that's physics make it. Oh, piss. Give me a second. My brain is overheating. I feel... This is too much mathematics, too much thinking. I'm a silly YouTuber. I like streaming video games. I don't like thinking about stuff. Wait, did I get this right? That the derivative... Like the sum of all derivatives, what would that mean though? Sum of all derivatives. Wouldn't that be an integral of a derivative? Oh, it would be the integral of a derivative, because right here, the derivative would be basically a straight line. That's g prime of x, and right here it would start at 0, then it will go up, then it will go down. No matter what the shape is, there is a point where the slope is equal to what it is in linear case. I really like using derivatives. Very cool proof of MVT. Huh. I don't know, I'm stumped. That was just a quick thought I had. I should get back to animating. I really like thinking in terms of functions, mainly because it's really useful in Blender. I mean, obviously it has to be, yeah, because the bell has to basically at some point Yeah, because when you have a line, the bell has to at some point like cross this line, because otherwise the derivative would always be smaller, and therefore the integral below the derivative, therefore this would be basically smaller than the integral of this. Obviously, both of these sign from A to B. Yeah, because then the area, because if this curve was always below the line, then lines, that's it. Oh my goodness, that's actually pretty cool. Yeah, and because of that, in the middle, it has to go faster because this area starts smaller than the line. My goodness, that's actually pretty awesome. Oh wow, I am right now making a video about animation, about math, and how you can use math, and I am gonna add it there as an additional example because that's so over-engineered. That not even over-engineered, that's overthought. Math is really cool. I can explain rigorously if you want to. Oh, please do, because I know my proof is kind of a, I know, geometrical one, I suppose. Mostly the fact that this area would be smaller if it was always below the line, which means it has to cross at some point. If it's gonna cross, then it's gonna have a point touching it, which means it has to be equal. Comments right now if it needed. Oh, hop on in. I didn't want to... Actually, I do have a question for you, if you don't mind. Hold on, let me give you privileges. Permission. There we go. You're gonna have a flame privilege. There we go. You're welcome. View channel. Connect channel. There we go. That was an exclusive flame privilege before. Well, hi the Red Blacks.
Hi there.
Hi, hold on, let me make you a bit louder.
On the stream.
Yeah. Welcome.
Right.
There we go.
Alright, I should mute the stream I have on my PC so I don't hear you speak the same things twice.
Yeah, we're gonna hear me without all the modifiers and parametrics. You're gonna hear raw make it. Exclusive cut.
Raw and sensor would make it. Alright. So, what's your question?
Well, actually, I mean, I think I get it now. It was just, I had a thought, which was basically, oh yeah, the Bezier has to be going quicker in the middle than the linear, because its derivative would be higher, and that's because it starts lower. So if the derivative of the Bezier starts lower, then it has to then go higher in order to make up that difference. And if the derivative is going higher, that means it's changing quicker, which means the animation of the Bezier would go quicker in the middle than the linear. I mean, that, but I do have a question.
Yes, that's mostly it.
But I do have a question, which I don't know if you will be able to help me, but I really wish you could, I'll be honest. That is, I did already paste it in there, the topic, exact topic. I won't look it up, I'm just gonna use the interchat. And that's because I'm getting so deep into quantum mechanics that it's just becoming mathematics, like genuine mathematics. This is mathematics.
Lie groups.
Yeah.
I always forget it's not Lie, it's Lee.
Yeah, it's...
It was Norwegian. Alright,
what's really funny is that this is basically quarks. This is how quarks were invented at this point. I can't even say discovered. This is how they were invented as math. So I really would like to know what Lie groups are, because that would help me out a bit.
Well, I can explain the definition, but I think Scarlett is probably better at handling such stuff than me, because they do mathematical physics and
just
probably
group.
a lot more differential geometry than I do. Groups in general, I can explain it pretty well. But the basic theory of groups is a lot about finite groups, because when groups are finite, you have a lot of combinatorial relations that give the theory a really good structure. But Lie groups are usually infinite. I mean, they're always infinite.
Okay, so...
They can be finite too, but they're not interesting if they're finite.
I will take groups, because I'll be honest, I don't really have any standing. I'm really awful with sets in mathematics. I prefer calculus, to be honest.
What do you mean? Everything is sets.
I know, that's what's so upsetting. Oh, so annoying. I don't like to think
Not
it of
everything is
sets.
sets. Everything is classes.
Everything can be a set if you're stubborn enough, though. I have seen people describe wild
Yes.
things of sets, and it always pisses me off because I don't get sets. I don't understand what
No,
they are.
the truth about such things as foundations is that, well, I mean, it's philosophy of math, but like most mathematicians, I think I'm a Platonist, so I do believe that like functions and derivatives and stuff have some. I mean, they exist independently of us. So sets are just a neat way of knowing that what we're saying is correct, but truly we're describing objects that exist on their own. So foundations don't really matter that much as long as they make sense.
Okay, I'm good. I'm good. That's a good quote to
I
go
mean,
in with
I
a
guess that's the
video.
physicist's point of view, but I guess I was always quite bad at doing physics, but I
The
guess
thing
I
is,
think like
physics is
physicists I
a
do math.
physics is such a, by the way, no, upsetting. That's no even upsetting. The thing is, physics is such a massive field. It's a similar thing as chemistry. So a lot of people, the reason why I made the recent chemistry video is because a lot of people claim that they don't like chemistry, but once you get deep enough into theoretical chemistry, it just becomes physics. And physics has the same thing, except if you go deep enough, it becomes mathematics. Where, I mean, I really can't stress enough how Lie groups really well. I don't know if it's going to be here in history. There's no examples. If it's relation to quarks, basically. Quark, not going to be. Okay, I could pull up the textbook, which I use as a source for the video. But basically, in this video, the introduction, that's the textbook. I hope I'm still logged in. I am not. Damn it! Now it's once again gonna take. Okay, just you have to just trust me because it's gonna take me a bit to log in again into an archive. But basically, the way quarks were invented is that someone just was trying to describe the property of the proton and the neutron, page 90, if my memory does me well. And so they came up with this mathematical, they basically applied the mathematical theory of sets to them and tried to figure out what combination you would need in order for that problem. So as far as I understand, I am probably going to be wrong here because, as I mentioned, I don't understand what sets are or groups. The way it works is that we have a proton and a neutron, and then it is a mathematical question of how many things would you need for those properties of a neutron and proton to exist, and what would be the properties of the underlying, I don't know what it's called in objects, whatever. So that's what I need sets for,
Okay.
and groups mostly.
I mean, you, you probably don't really need sets. I mean, like sets are just a neat way of talking about mathematics. Like they're a language. They're basically a language. But I mean, you just use set theory because it's convenient to use. I mean, most of the time, some people don't like it. That's a whole debate. But no, I think that the physicists would be more interested in the theory behind, well, groups. I mean, groups
Right.
depend on sets, but they're really not the same thing. They're really not the same thing. Like a group has a lot of structure. A set has a very poor structure. Uh, Basically, what I'm saying is that groups are, in a sense, more interesting.
Okay, so what is a group?
All right, so the basic idea of what a group is that it's mathematical objects that I actually I don't really want to show my face on stream, and I
I
don't have a
can
mask like you do. So
I can just pull up a whiteboard.
Wayfair will do.
I can pull up a whiteboard if you want. I know if
The
it's gonna
basic
be.
the basic idea of what a group is that it's more or less a mathematical object that encodes symmetries. Maybe we should do a new board.
Wait, can we save this one first? Or because oh,
Um,
you can just okay, cool.
yeah, you can just make a new one.
Cool. This is gonna be a math board. That one's gonna be a chemistry one.
Right.
I'm gonna need a physics one for Remco.
All right, so um, I'm going to talk about how groups were invented, historically speaking, sometime later. But basically, think of a cube.
I'm good at thinking of cubes. Yeah, I do
Right.
Blender.
So I only know how to draw up to continuous deformation, but pretend this is like a proper cube.
Okay.
Right. Right. So think of a cube in 3D space, and think of what volume this cube occupies.
Right, that's if...
Now, if I hold the cube in my hands, I can rotate it around, I can move it around. All right.
Yep.
Think of all possible rotations of the cube that make it think of all possible rotations that bring the cube back to the same volume, but maybe they like shuffle the faces around. So,
so
instance,
basically like a oh, I'm gonna absolutely ruin your beautiful... So basically like a rotation this way. I know I drawn as a square, but I mean as a this kind of rotation, which brings it back.
Yeah.
And then
So
by
for
90
instance,
degrees...
if I just take this cube and make a copy of it. So basically, so the rotation you described, it would like say this face is colored red. Well, then you'd have the back face colored red after because it would have been well moved around, and if the front face was colored green, then it would end up on top.
Yep.
Right. So that's what your rotation would do. All right. Well, so these rotations are, in some sense, symmetries of the cube. I mean, I think you can see that. Yeah, but basically, the important thing is that we figured out that in a lot of cases in mathematics, in a lot of situations, we have some notion of symmetries of an object, and we basically abstracted away the concept of a symmetry, and we ended up with groups.
So if I... So okay, so basically it's a way to describe combinations. No, wait, not combinations.
Well,
the reason why I think of combinations is because if I rotate the cube 90 degrees forward and 90 degrees to the left, that's equivalent to it rotating 90 degrees to the left, but in a different way.
Yeah, so, okay. That's the important thing. Basically, the cool thing about rotations is that you can do one, and then you can do another. And it's like this operation of... Basically, it's like function composition. Like, you've heard of g of f.
Mm-hmm.
That's basically the same thing. You can do one thing, then another thing.
Yeah, and g of f wouldn't, in this case, be equal... No, wait. Because of rotation, g of f wouldn't always be equal to f of g.
Yeah, that's true. You can
I know,
find an
that's...
example with
I'm
rotations
just
of the
trying to
cube that
contribute.
shows that this isn't always true. But basically, how do we abstract away everything? Well, so what the definition of a group is that it's a set G. So a set is just a collection of things. We don't need to know exactly what it is precisely. Just a collection of things. Wait. Is my internet failing?
No, we can hear you well.
All right. I just got disconnected from the whiteboard. I don't know why. That's no problem. And you've got some kind of way of combining the elements of G. So an operation, basically. So for instance, in the example of the cube, the G would be all possible rotations, and the little asterisk would be doing one after the other. So what I mean is, when I say operation, we call it composition law, at least we do in French. I think it's the same in English. It's basically a function from g times g to g. Do you know what the product of two sets is?
I have absolutely no idea. No, wait, product. Oh, isn't that the logical operation of... I know we're talking about the same product. Let's just assume no. My knowledge of sets isn't great.
Basically, it's just pairs of elements of G, but the order matters.
Makes sense.
So
okay.
It's ordered pairs. AB is not BA. It's just a way of talking about two elements of G at the same time. It's basically just this.
Yeah, that makes sense because I know it's abstracted already, so it doesn't actually... It's not exactly that, but it makes sense why it would be useful for the ordered matter since rotate left, rotate forward is different than rotate forward, rotate left. When this
exactly, that's the point. That is exactly that. And so, well, so an operation is kind of like a function with two variables, but since we don't really think of it as a function, but more of an operation, we usually note it between the two elements that we're operating with. So we usually use infix notation. And well, that's just a set with a composition law. That's not a group yet. We need some suppositions. People call them axioms. We don't really do that in France, but I guess I'll call them axioms. So basically, there's three properties that you need for this to be a group. The first one is called associativity. Associativity, I don't really know how to pronounce it. But basically says this. So it basically says that you don't really need parentheses. So for instance, if you take usual addition, you never use parentheses.
Yeah, it doesn't matter. A plus in parentheses b plus c is equal to a plus b in parentheses plus c.
Exactly. It doesn't matter. No, maybe you're thinking that this property is kind of random to ask for, but
well, I mean, no, I know it's important.
It's important.
Yeah, a year ago or so, I have.
At the start, but it becomes really important later.
I mean, the thing is, a couple years back, I did some stuff with quaternions, so yeah.
Yeah, right.
It's handy.
Quaternions are still quaternion is still associative. It's
yeah, I know, but I went for but I was going from real to imaginary. Real to complex to quaternions to octen, and then the 16 ones, and so on and so forth. And they basically lose each property as it goes on. So yeah.
Yeah, we've got a PhD student in my department who does things with octonions.
Oh my! What would you even?
I don't know. They do. She does number theory. I'm not really clear on what exactly she does. Since it's well researched, but
that's madness.
I know it scares another of my friends who's also a PhD student.
I mean, I've never heard of octonions being used anywhere. To be honest, I heard of quaternions very recently because in Blender you use quaternions in Blender. Funny enough, so quaternions.
They obviously, if they didn't have applications, they wouldn't have a name.
Well, okay, let's hold your horses there. It's math, okay? Having mathematics without an application, having math without applications is like a stage that every single tool goes through. Eventually, everything has an application, but
I mean, I'm sure that some people have managed to apply somehow octonions in physics. I just don't know how.
I mean, I'm pretty certain they have a name actually because there is like a way to generate them. So you just pick a power of 2 and you get a set of.
Yeah, it's called the Cayley-Dixon construction. Don't really know much about it. I mean, it's probably described somewhere on Wikipedia. But yeah, you can always double dimension and get a new algebra.
I guess octonions would be, I don't know, patience. I don't know. I don't want to guess. I'm assuming it's complex.
So the next property that we want for a group is that there is what's called an identity element. Basically, think of the cube again. Technically, doing nothing is a rotation of the cube. It's an operation, It brings it back to the same volume, right? It just doesn't do anything. And how do we know that it doesn't do anything? Well, it's because that basically we want for there to be some element E in our group, such that for any other element A in our group, well, basically operating with E doesn't matter, doesn't change anything.
So kind of like 0 for adding or 1 for multiplying.
Exactly. Okay. Absolutely. Numbers with addition, our group, actually, we'll see that with the third extremes. With multiplication, it's a little bit more finicky because 0 exists. But yeah, basically that's it. And so in the case of the rotations of the cube, the identity element is just the operation of doing nothing.
Makes sense.
All right, so the last axiom that we want is, well, it's the one that really makes the whole symmetry notion work. Basically, the concept is that when you have a symmetry, you can kind of do it backwards. So for instance, if you rotate the cube, you can basically rotate it in the opposite direction. When you add 1, you can undo that by adding -1. So that's the notion of inverses. So we want that for any element of our group, there should exist another element, B.
By the hungry by for now. I'm sorry. I just want. I never know when to interrupt when I want to reply so on. Like I get so basically adding. So basically negative numbers in this case. In this case, it's the same for multiplication and addition.
Yeah. When I did my whole my little talk on groups, I always compared rotations of the cube to multiplication, addition, and subtraction to understand really what were the differences between them. And so, right. So for any element A, we've got another element B, such that when we operate with A, then with B, in any order, we get back to the start, which is the identity element. So 1 plus minus 1 is 0. If you do a rotation, then we rotate in the opposite way, then you get back to the state you were at the start. So basically you did nothing, which is again the identity.
Right.
Alright, so
it just hit me. I'm sorry, it just hit me how that these are operations, not the. Okay, that's abstract. Okay, it's fine. I'm good. I'm good. So far, I'm with you.
That's the kind of the beauty of algebra. Basically, it's heavy machinery for math. And then when you encounter a group in mathematics, you can say, "Oh well, it's a group, and now I can apply all the group theory."
Yeah, I mean, this really feels like
we talk about this particular situation.
This really feels like mathematicians just running out of physical objects, so being like, "Hey, let's talk about the mathematics of the mathematics."
Because mathematics of mathematics is either logic or category theory.
Yeah.
All right. So these three axioms are the definition of a group. So what a group is mathematically is a set with some operation on the set that is associative, that has an identity element, and such that every element has an inverse. And that's just it.
Okay.
That's what a group is. Then from this definition, we can derive many beautiful theorems. And basically, groups come up everywhere in math. And that's maybe the good place to explain how groups were invented. So basically, the whole idea started with the Galois, the guy with the polynomials equation that died at 20 years old. So basically, what Galois was interested in doing was solving polynomial equations. So for instance, you know the quadratic formula.
Right. I have heard about once or twice.
But basically what the quadratic formula does is that it takes in degree 2 polynomial. So degree is the highest power of x that appears in your polynomial, basically. And you give it basically the coefficients of your degree 2 polynomial. It spits out the roots. What are the roots? They're the x's that are the solution to the equation that I wrote on the whiteboard. So numbers that when you plug into your polynomial, they return 0. We're interested in roots for many different reasons. And the thing is that the quadratic formula, the quadratic formula is pretty simple. It only uses square roots. That's the most complicated operation that comes up in it.
Right. I am following.
So people basically figured out the quadratic formula, I think, a really long time ago. I think it was probably in the... Was it known in ancient Greece? Maybe it was known before that, but it was figured out a very long time ago. And then people started wondering, all right, so we know how to solve degree 2 equations. What about degree 3? What about degree 4? What about degree 5? And so on. And formulas were found for degree 3 and 4. They're really ugly and they're don't
Yeah,
really
I remember
serve much purpose,
Mathologer,
so
I think, dedicated a whole like 40-minute video to, I think, either cubic or the hypercubic one. It was called hypercubic, but
who was it?
Mathologer dedicated a whole video where it was just the equation had to be broken down to 3 separate pieces, and each one tackled like a 10 to 20 minute long segment because it's just.
I was once given homework where the objective of the homework was to basically derive the formula for degree 3, well, a formula for roots of degree 3. Actually, searching for roots of degree 3 polynomials is also how we came up with complex numbers, because at some point we needed to have square roots of negative numbers, and people were like, well, it seems to work, even though it's kind of illegal.
It makes sense that you would need sometimes imaginary numbers for third powers, obviously, when you want to find all solutions.
Yeah, actually, imaginary numbers work really well because you've got a beautiful theorem, the fundamental theorem of algebra, that basically says that in the complex numbers, any polynomial equation has a solution. That's a really strong theorem.
That's actually, wait, how is that proven?
Actually,
Or was
the
it
theorem
like
is
an...
called the fundamental theorem of algebra, but it always
Oh,
uses a
it's...
little bit of analysis. And well, there's an elementary proof that I have in some of my books that basically does a lot of inequalities, and in the end, you see that it checks out. But the quickest proofs I know use complex analysis. So
Oh,
calculus, but with
so we
complex
don't
value
want to
functions.
get into it. I gotcha. All right.
Um, I mean, there's also a more algebra-oriented proof that I had in one of my exercise sheets like a week ago, but
I mean,
you
it's
need to
fine.
use
It's,
Galois
that could
theory
be...
for it, so it's overkill.
Yeah, I feel like
But
I'm
basically,
getting
complex
too deep.
numbers are actually a really natural thing to consider, and they work very, very well with polynomials. That's what I'm saying.
Yeah, makes sense. Makes sense. Makes
Um,
like intuitive sense with, as I mentioned, solutions where you get roots of squares. I mean, not roots of squares, roots of negatives.
all right, so now the theorem tells you that, I think it's a term that by Gauss and D'Alembert. We call it the theorem of D'Alembert-Gauss, but I mean, I think Gauss proved it because it's Gauss, but uh, I don't know if D'Alembert actually proved it. But basically, it tells you, okay, a root exists, but it doesn't really tell you how to find it.
That
So
such a
people
mathematics
were,
moment.
yeah, it's typical mathematicians always, they always do non-constructive proofs and stuff. And basically, so people still wanted to have, well, formulas for roots because, well, I mean, I won't say they're useful, they're not really used in practice, but it's nice knowing that they exist. They are used because, computationally speaking, they are less efficient than just trying to approximate the roots with some other method based on calculus, basically. So formulas for degree 3 roots and degree 4 roots were found by Cardano and Ferrari. Oh, that was a long time ago. It wasn't like the 1600s, if I'm not mistaken. But nobody could come up with a nice formula for degree 5 roots. And what Galois proved is that you can't. That's the really strong thing.
Boy.
Precisely speaking, it's not like there's no formula at all. You can express precisely the roots with some elliptic integrals, I think. I never saw formulas myself, but I know they exist. But you can't find a formula that only involves addition, subtraction, multiplication, or division, and taking roots, taking nth roots. You can't. And Galois
it
proved this using
makes
roots.
it makes intuitive sense again. That's because it's like a higher order operation, and you're trying to basically create an equation for it using lower order operations. But the proof, I'm assuming, is going to be insane.
It doesn't make intuitive sense because you're technically allowed to use fifth roots. You're allowed to use roots of any
Then
order
it doesn't
that you
make
want.
sense. Never mind. Take it back. Okay.
With only
Carry
square
on.
roots, maybe the proof is a little bit easier, but basically what Galois did was that he basically invented modern algebra. I'm exaggerating a little bit, but I'm exaggerating quite a lot actually. Galois didn't come up with the definition of a group I just gave you, but he came up with the concepts. Basically, he was interested in the symmetries of roots of polynomials. And what he proved was that, well, you have a nice formula for the roots if the group of symmetries of the roots is what we call a solvable group. Basically, it's a nice property. And when you think of the group of symmetries of certain fifth degree polynomial, you can show that they're not solvable. None of this is trivial. Everything is hard in what I'm saying.
Yeah, I got it. Yeah.
Everything is hard. But that proves the theorem. There are some degree 5 polynomials that you can solve with elementary operations. And that's proved by groups. But basically, the symmetries here are symmetries of some number system, generalized number systems, what we'd call a field. It's another algebraic structure, it's a little bit more complicated. And so that was the first major success of group theory. And well, people kept on studying groups for many reasons. And so that's very, all of what I'm saying is very discrete example of what groups are. For what interests you in physics, so Lie groups are basically, well, they're a group, but they're also a continuous object. They encode continuous symmetries. That's the main difference.
Okay, that makes so makes sense. It's a typical sums versus integral kind of thing, right?
Yeah, it's the typical thing. Basically, Lie groups are groups, but they're also geometric objects that are smooth.
So okay, okay.
I could give a precise definition, but that would require a lot more
I
time. But
don't know if that would
basically,
help. I'll be honest. I don't think that would
think
help.
of a sphere. Think of a sphere.
Right.
People say that the sphere is a surface. I mean, I'm talking about the usual sphere, not a high-dimensional sphere or whatnot. Just the usual sphere, the surface of a ping pong ball. What do people mean when they say it's a surface? Well, basically, if you look very closely at a ping pong ball, if you look very closely at a ball, oops, if you look very closely at a ball, if you zoom in on it, well, it looks like a plane. That may remind you of, well, if you take a differentiable function and you zoom in on its curve, it looks like a line, and the slope is the differential. That's the
So
same idea here.
it okay. So basically, hold on. So this is basically this.
Yeah.
Getting to so is it going to be? Can I try to predict where this is gonna go? Because I'm gonna be honest. I have a feeling that I kind of get it, but I want to make sure.
Obviously, you're not. Obviously, I'm not expecting you to have like a solid understanding of everything I'm talking about here. Like,
I mean, okay, I'll be honest with you. I'll I'll be honest with you. The only other place where I have seen this kind of notation in this density was when I looked up Principia Mathematica as a joke. That was the only other place where I've seen it. So, but so far, so far I get it kind of actually. This makes sense.
Principia is about founding math. Like people were really upset about how math was founded back in the time, and Russell and Whitehead tried to ground it in pure logic. But don't worry, it's not really. It's really not the same thing. The math most mathematicians do is, in a sense, concrete. Like there's intuition behind it, kind of like physics.
I mean, I would even say
not really the same way of thinking about stuff, but
I would even say it's even more concrete.
To me, the cool part is the understanding part.
The thing I would even say it's more concrete than physics because in mathematics we had some underlying assumptions which we assume to be completely correct. In physics we don't have that. In physics you're never gonna have unless it comes from math.
You need to remind yourself that you're working with a model that is most certainly wrong. In math you don't have that, and that's a thing you're gonna
The thing is, like in mathematics, I don't know what some kind of the most basic axiom you can think of. I don't know what that would be. Something like something that no one would question mathematics.
Well, I think. Well, you can basically. Well, there's an axiom of set theory that is that if you take two things, you can make a set that contains only the two things. It's called the pairing axiom. So you can pair things. Who would have thought?
Yeah, that's. I mean, it makes sense. In mathematics, the axioms are always so, like, comically obvious, but it makes sense that they're obvious because you still, even if something is obvious, you still have to mention it. You still need to acknowledge that fact. So, like, if in mathematics,
axioms are the thing that we take to be true without questioning it because we need to start somewhere. It's better if they're intuitively true.
Yeah. So the thing is, in mathematics, you have these axioms. In physics, even at this point, we don't even know if gravity is real. Like, we assume it's real, we do see it, but we don't actually know what it is at all. Relativity is extremely accurate. Relativity, which is, I mean, I know I always say it, but the amount of weed Einstein had to smoke, it's incredible. I know if you, I know how familiar you are with relativity, how it works.
I actually have not done any physics.
I mean,
in the past
the thing
year,
is,
actually.
relativity is actually really mathematical, but it's the thing is, it's basically.
I know that it's really close to differential geometry, and I've actually taken a differential geometry course, and that's related to Lie groups. I was going to talk about that. But I haven't done like the physicsy part of relativity. I absolutely have no idea what it looks like.
I mean,
actually, I don't think I know enough math to understand relativity properly.
Oh, I no, I think you do. It's I mean, okay, depends on what you mean by understand relativity, because for me, I don't actually need to know a topic in depth, because I'm not a, as I keep mentioning, I'm not a mathematician, not a chemist, not a physicist. I'm just a random guy who makes YouTube videos.
You know that relativity talks about things like metric tensors and curvature and stuff like that, and that's a little bit further than than the differential geometry I did. Maybe next year I'll have all the background needed to understand it.
It's really just I just focus
it's a
on
little
the
bit further than my math knowledge. And also, there's inadequate dog that brings up something interesting in the chat.
Euclid's fifth postulate. Yeah, I see.
Yeah. Well, basically Euclid was
well ahead of the guy.
The ancient Greeks came up with the idea of proving things. I think. I mean, they probably didn't really invent the idea like themselves, but until other people already discovered proofs. But
can you imagine
Euclid basically rigorously did geometry. Euclidean geometry in the plane.
That's the thing that pisses me off so much about philosophy, and I very recently mentioned it, that philosophers just take credit for stuff, and it's like, oh yeah, we invented proving stuff, yeah, we invented proving and basically making sure that things do stuff. Parallel postulate. Oh, that's a good one.
The cool thing with Euclid is that he went and he said at the start of his books, The Elements, he said, all right, so I'm taking 4 axioms to be true. And these are all obvious things, like between 2 points there is a unique line that passes through them.
You know what's really funny?
Or if you have 2 lines that intersect at a right angle, then all the other angles are also right angles. And Euclid basically tried to rederive all of the geometry knowledge that they had at the time using his axioms. And at one point he came across something that he just couldn't figure out. And I can actually explain it a bit. I'm not a big logic or geometry guy, but that's something I know. Yeah, so a straight line, yeah. Right.
I'm sorry, I'm just thinking for saying. What's really interesting is that, if I'm not mistaken, that's what I meant when I said that, like, advanced physics really often just becomes more mathematics than anything else. I remember a textbook, was months ago, so it's very easy to remember, but I remember a textbook which I used to learn about relativity, and basically the first chapter was that you have to forget everything you know about physics and the axioms, right? The things that you needed to use was actually, if I'm not mistaken, Euclid's postulates. I can look up the textbook, but it really clicked in my brain when it said that 2 lines are drawn which intersect in a third way. This one was one of them, and there was 5 of them, and I remember they rejected one because one wasn't general enough. One of these wasn't general enough for general relativity.
Actually, I can explain that. Like, I know this part. So if you look at the whiteboard, what the fifth postulate says, that if you have a line and another point that's not on the line, then there exists a unique line that passes through the point that's parallel to the first line.
Makes sense.
So that's obviously true in the plane.
Yeah, but
it's not true on a sphere, a surface in general.
Wait, no, it would be true on a sphere. What am I talking about? Actually, no, it wouldn't.
Oh, that's a misconception I had as a kid, and I cleared
yeah, no,
it
it wouldn't, because it would have to curve. Yeah, it would have to curve. That's true.
Basically, the problem is that on a sphere, it's not really clear what we mean by a straight line, and that's something
so basically,
that flat earthers often misunderstand, and I misunderstood for a long time.
So if you basically have a line like this,
is actually not a straight line on a sphere.
Yeah, it has to continuously curve, because if it was a straight line, it would go like this basically.
Yeah, so what we mean exactly when we say a straight line is a path that minimizes distance. So basically the most efficient way to travel from point A to point B. We call that a geodesic, that's the fancy math word for
and
it.
and if you want to start here, end up here, then this would be the most efficient.
Exactly. The geodesics on a sphere are arcs of great circles that, well, have the biggest diameter possible. And it's obvious that if you take two great circles, they're going to intersect somewhere. So any two lines on a sphere intersect.
I would
There are
have
no
defined.
parallel lines.
Yeah, I do think that this one was the one that the book rejected, actually, because
Yeah,
in
because
general relativity, you wanna.
basically what people thought is that our universe is Euclidean, so we've got Euclid's postulate that works, and that's the thing relativity breaks. Our space is curved in some way.
I just really like it because it's madness.
And basically, what relativity says is that it's gravity that gravity is just like us interacting with the curvature of the space, if I'm not mistaken. But again, maybe ask a natural physicist about this.
You know how convenient it is to actually to finally have a mathematician? We spend so much time without our designated mathematician, just without the mathematics guy.
Yeah, so for the people in the chat that are asking who I am, I'm some guy that make it found on the internet, but I'm doing a master's in math.
To
And
be
I'm a
fair,
first year, so
every single person that has ever joined on stream could be described as some guy that make it found on the internet. The thing is, Reblax is one of our, as I proclaim them, experts in certain different fields.
Really not.
Yeah, every single one of them says they're not. Don't listen to them. But so basically, whenever I'll be doing a mathematics, actually, no, I don't think I'm gonna actually use you for mathematics videos, simply because the mathematics I would need to the level, the advancement, I would need to make so advanced videos. I don't think they would be watchable.
I don't know. I can help with like
But
lower
I
level
mean,
mathematics also.
I mean, no, I am still gonna use it for advanced mathematics. It's gonna be in physics videos because the thing that's what's so annoying is that the extremely advanced physics still can be displayed in a really pretty way and in a really intuitive way, uh, even if it uses incredibly difficult mathematics behind it. But I still need to answer the mathematics to make sure that what I'm saying isn't a lot of garbage. Although I do want to switch up my type of content every now and then. I want to make more videos about the history of science, and I do believe that the history of mathematics will be the most interesting one because it's always a circle, as in, or actually not a circle. It's more always the history of mathematics always looks like this. So basically, someone is trying to figure out a problem, and they create like an extremely complex theory for it, something incredibly difficult, incredibly complex, and just the whole field most of the time. They just invent a new field of mathematics to end up at the conclusion, and then once that is invented, there's like an obvious short path forward. So, for example, oh, would be a good example. Mathematics is really easy to re-explain. That's because once you know the answer, it's really easy to walk backwards to find like an intuitive solution. So I really want to make videos in this sort of form where actually with sets, that's actually a great example. You know, start with the quadratic, then cubic, then actually the fourth one I might skip, and then the fifth order, which is basically impossible, and how in order to prove that you need sets. However, once you already have sets are actually extremely simple. Does that make sense?
I mean, actually, the thing is that Galois didn't really know about sets. That's the thing.
Didn't he even?
That's
Did I
sets were
misunderstand?
invented more or less because Cantor was wondering about. I mean, actually, I don't really know, so I'm not going to speak about this to not say something false.
That's fair,
But I
wait.
know that Galois didn't know about sets because groups are.
Oh,
I
groups.
mean, the way
Sorry. Oh
Galois
no, I meant
thought.
groups. Yeah, you're right.
Oh, all right, right, yeah. Then yeah.
I meant groups. I just.
Galois generally invent the formal definition of groups I gave you. I gave you before, but basically he saw groups as embedded in some kind of. How do I explain this simply? Actually, basically, there are some important groups that we call the symmetric groups. They're in some sense universal, and Galois only thought of smaller groups contained in symmetric groups. He didn't really think of groups on their own. Um, I mean, for instance, you're used to think of a sphere as something that exists in 3D space. You're not really used to think of a sphere as just something that exists on its own.
Yeah.
That's more or less the difference that...
That's the difference between physics and mathematics, basically.
Yeah, basically, Galois always thought of...
That's the sense.
Always thoughts of... basically, he always thought that of groups as something that shuffles things around.
Yes, kind of how people really often, the opposite of how people really often think that imaginary numbers don't exist. As in, they try to imagine imaginary numbers as a physical quantity rather than them existing as a mathematical tool. Is that?
Yeah.
Yeah.
Then again, imaginary numbers kind of exist if you know, well, if you know about like phase, basically rotations.
Yeah, but that's the thing. When you think of that's why I said when you think of quantity, as in, you know,
yeah,
when you're trying to,
they're not really what you'd call numbers.
Yeah, but then everything in mathematics in that case could either not exist or could exist simply because, well, depends how you define existence. Is a consequence of something real? I'm pretty certain Vsauce made a whole video, do chairs exist? Precisely about that. Oh, is a chair or collection of molecules? The thing. Does a set with all sets that do not have themselves as a subset exist?
It doesn't. At first, we didn't think of it, and that's why basically it was Frege. It was more of a philosopher and logician than a hardcore mathematician, and basically he published a treatise on set theory, but he didn't think of such paradoxes. And so basically, he allowed some kind of operations with sets that allowed Russell to, well, make his paradox happen. And so basically, his theory didn't really check out. And now we've understood what the problems are, and so we've corrected them. So now we can for sure say that what you're speaking about is not a set.
That's all.
So
I'll be honest. That's actually so. I'll be honest. I read that as a bit to throw the ball to you. I wasn't expecting you to be like, oh no, yeah, we know they don't exist. That's such a mathematician moment, though.
Like someone, I mean, obviously, it took time to figure out how the foundations of math should work out.
Yeah, but still,
now we've more or less settled on a list of axioms that seem to work for now. Maybe we'll find out that actually they don't later, but I hope not. I like them.
Yeah, but I mean, it's still so funny where basically you can say like, oh yeah, it doesn't exist, and it's not even that it doesn't exist as in, oh, it seems paradoxical or something. No, we have proof that it doesn't exist. Such a nice change of pace.
It's not really that we've proved that it doesn't exist, but it's more that we've made it we've made it so that the theory basically doesn't really allow you to say the set of all sets such that you're not really allowed to say that sentence, so you can't invent your paradox that way.
Yeah, makes sense. But funny,
we've not proved that it doesn't exist. We've not proved that math is actually consistent. That's impossible.
No, but funny enough, these sort of paradoxes in physics are fine. Physicists just walk around them, because that's the difference. Mathematicians just obliterate paradoxes out of existence with facts and logic, absolutely owning them, and physicists just calmly step aside.
Well, it's because, well, using the way why we fear paradoxes so much is that basically, if we get one paradox, the entirety of math collapses, basically. Like when we write out the rules that allow us to make deductions about stuff, like the formal rules, if there's something that is both true and false at the same time, then everything else is also true and false at the same time. So basically, math doesn't really tell you that's true, that's not true. It tells you nothing.
Yeah,
so
basically, math hinges on it being perfect, basically.
Yeah.
So, if something is a contradiction...
There are some people that have tried to work around that, but in mainstream math, it's commonly accepted that if we have one contradiction, everything collapses.
These mainstream mathematicians always just... cherry pick. I don't know why. It just sounds really funny, mainstream math. But right, yeah, because in mathematics, if something leads up to the contradiction, then the whole lead up also doesn't make any sense. That's proofs by contradiction, if I'm not mistaken.
Yeah, exactly.
So that way you would just prove by contradiction math out of existence, basically. So that would be fun. Do imaginary sets exist? I don't know what an imaginary set would mean.
Yeah, same.
Because imaginary set. Well, I'm pretty certain that sets. Yeah, I don't know how imaginary set would be. Square root of negative set. Yeah, but set isn't a number.
Actually, I read something that talked about negative sets recently.
Come on! I can't even say that set isn't enough.
It could be some paper that I read and I present to pass a class, pass a course. But I mean, there are some generalization, but imaginary sets, never heard of them.
What kind of mathematician will I can't even be like, oh, yeah, sets and them? Well, actually, I don't know. I'm gonna. That's math. That's math.
Yeah.
I'm surprisingly awful with math. The only math I'm good at is functions, but that's simply because I used functions to describe things so often that I just now think in terms of functions. That's why I don't really understand. I don't really like it when people say that, you know, they're never gonna use the math they learn, because it is my genuine opinion that you could use any piece of math for anything if you're just good enough. Like you could optimize, and you could figure out what's the most optimal time for you to wake up in the morning using knot theory if you're just good enough as a mathematician. I genuinely believe that.
Well, I mean, you basically proved your point when you reinvented the mean value theorem.
Yeah, like that's the thing. But unfortunately, I can only do it for calculus.
I mean, I guess I do math because it's interesting, not because of any applications. But it's true that's. I mean, I make a lot of jokes about parallels between math and the real world very often. Because that's something.
I'm never going to use the law of cosines for anything in life. I don't even know which one is the law of cosines. Law of cosines. The thing is, because I'm not a mathematician, I do know a lot of these, but I don't know their names. Simply because that's a lot of words and I have a tiny brain. Law of cosines this.
Yeah, it's a generalized Pythagorean theorem, Al-Kashi theorem. But this one is actually useful in
it seems doing extremely tame. Yeah. In comparison to other mathematics, like, I don't know.
The mathematics that I do, you're most likely never going to learn them in the first place, so you're never going to apply them. So.
The thing is, because most of the mathematics I've seen when it comes to the advanced ones, it's more like about. It's not really the classical way of doing equations. It's more logic, except logic. Yeah. It's like competitive logic, basically. That sets being, groups. I keep saying sets when I mean groups. Groups. Okay, I have to learn. It makes sense how they would be applied for quarks, by the way. I don't know if it's just me, but to me it makes sense how groups would be used for quarks.
I know that groups and, actually a lot of things in algebra have deep connections to physics, but I just don't know them. I just know that, like, my academic tutor actually works with some things called topological quantum field theories, so it's probably related to physics in some way.
Quantum field, that's a combination of basically electromagnetism uses that combination of relativity and quantum mechanics, because just quantum mechanics by itself wasn't difficult enough, so we just have to chuck that in there.
All right. But so basically, if you want to know what a Lie group is,
it's basically I mean, the way I think of it is continuous group. Is that close?
That's basically the thing. It's not just a continuous group; it's actually a smooth group. But yeah, basically it's.
Yeah, I know it's gonna probably mean a different thing.
It's a geometric thing, and for instance, if you look at the symmetries of a smooth thing, well, it makes a Lie group.
Oh, so oh yeah, so a sphere basically, how when it comes to a cube, you have to rotate it by increments of 90 degrees. When it comes to
Yeah,
sphere,
actually,
it's
the
anything.
group of rotations of the cube has 24 elements, so it's very discrete. It's
Oh
counting.
no,
It's
wouldn't
discrete math. It's not continuous at all.
wouldn't Lie group be? Oh yeah, you did say it was infinite. That makes sense. That tracks
Well,
actually.
basically, the thing is that for a Lie group to be like something smooth, you can only make up something smooth with only a finite number of points. Like geometrically, that doesn't work out.
Yeah.
And in math, you don't get something interesting if you try to make something smooth with a finite number of points. I think.
What's a solvable
I'm
group?
almost certain that is correct.
What? Actually, I'm curious. What is a solvable group? That's a good
what's a
question.
group? All right, so basically, when you take a group, you can look at a smaller group that is contained within it that is called its derived subgroup. So you take a group and you look at a smaller group within it.
Mm-hmm.
It's the derived group. And you can do that again. You can look at the derived subgroup of the derived subgroup.
Yeah, because the
And
derived
so on and
subgroup
so
is a
forth.
group, so you can do the same
It's
thing as
also a
the other
group,
group.
yeah.
Yeah.
Basically, you can do this a lot of times. And so now a question. Now there's in some sense there is one group that is the smallest group. It's called the trivial group. It has got only one element. It's the smallest group there is. And you say that a group is solvable if when you take the sequence of derived subgroups, eventually you stumble upon the trivial group.
So,
Basically, if the sequence of smaller and smaller groups eventually gets to the smallest group,
so if
the smallest group.
wait, so would then Lie group be unsolvable?
Um, not necessarily. Absolutely no, no, no.
Is it because you can
Uh,
take just a single one and that would be trivial?
well, yeah.
Oh,
I don't have any examples because I'm not a big Lie group guy, but basically, if a group is commutative, that is, if A operated with B is B operated with A, then it's solvable. Because in one step you get to a trivial subgroup. So if you have a commutative Lie group, then it's solvable. Um,
Meg,
so
you
yeah,
said sphere has an infinite amount of axis of symmetry. Does that mean a sphere can have a rotational symmetry of pi degrees, or e, or other irrational number rotational symmetry of pi degrees?
yeah, yeah. These are all elements of some group of symmetries of the sphere. That's true. That's
Actually,
correct.
wait, could you give me an example of an unsolvable group then?
Um, for this, I'd have to well, the prototypal example is the group S5. Actually, I can explain it. Um, so that's the example that interested Galois, basically. So if you take the first 5 integers, the first 5 natural numbers, the 6 first natural numbers, but you don't include 0. So I don't want to get into politics. You can order them around. For instance, you can do stuff like this.
Wait, are you writing
You can
something?
shuffle.
Oh yeah, okay, sorry.
Yes.
Yeah, I see.
Yeah. Right. So you can look at all possible orderings of 1, 2, 3, and 1, 2, 3, 4, and 5. And for instance, you can permute. That's a verb. That's probably a verb. You can permute. We can switch. Is the proper verb. You can switch 1 and 2 around like this.
Right.
All right. Well, that's an operation on the set that contains 1, 2, 3, 4, and 5. And what you can do is you can do it again. For instance.
Oh,
And
and
that
then
would
it
give you this.
loops, and so you're never gonna end up
Yeah.
at a trivial one.
Yeah. So basically, you take the set that you consider as all possible orderings of 1, 2, 3, 4, and 5, and you've got this kind of operation here that you've got this operation basically,
Wait,
and it makes a group.
wouldn't then our cube be
Yep.
unsolvable?
Our cube has symmetry group S4 actually, not S5, and it's solvable. Our cube is solvable. That's because I know what group it is precisely, and that's not trivial at all. But yeah, it will be solvable.
So wait, so the group of this, I'll be honest, I don't understand. This isn't.
I mean, if you want a group that I can prove it's unsolvable, it's going to be a little bit harder to come up with an example, but maybe I can...
I mean, I don't know if the proof will help, because the proof is gonna be large.
Well, yeah, you'd have to understand what the derived subgroup is.
Wait, so if I take a cube, right?
Yeah.
If I rotate it forward 90 degrees.
Alright.
That is a subgroup of our group, right? Because now we're gonna have all of the rotations from first rotating forward. Unless I'm misunderstanding what...
Yes, if you consider all of the rotations that you can get by just rotating forwards a certain number of times, that's a subgroup. Yes.
Can't I then rotate forward again and once again have a group? And repeating that forever?
Hang on, I'm not sure what you mean actually.
Like when you have a cube of rotation, then and you consider group being, you know, all possible rotations, or rather all possible positions after rotations, then what would be the trivial group?
Well, the trivial group would be just the group with only one element. So basically it would just be the cube, but you're not even allowed to move it.
Oh, because I'm an idiot. Okay. I was thinking about it incorrectly.
It's fine.
I was thinking about it like if we had a group of all possible positions that our cube could end up in. But right here we have a group of all rotations to the cube. Not
I mean,
all.
it's more or less this. It's more or less the same thing.
I mean, no, it is different because a group of all possible positions in which cube could end up is infinite, or rather, all combinations of rotations. Because, well, it's every combination of rotation. There's always gonna be more.
I see what you misunderstood.
Yeah, I misunderstood that greatly.
Right. So when I start about rotations of the cube, you only look at where the cube ends up, basically. Like, for instance, if you rotate it forward by 90 degrees, it's going to end up in the same position that if you rotate it forward by 90 degrees 5 times.
Okay, yeah, now I get it. Okay.
So there's only a finite number of ways to like turn the cube.
Yeah, so like
so
final position of the cube,
yeah.
That was actually happening. What I thought was happening was like the path to get there, which is different.
I mean, technically, you could also consider the path to get somewhere, and that would also be a group. But
that would be a different group then, because
it would be infinite. Then it would be infinite.
Yeah, because in our group, 5 is equal to... That's dumb. In our group,
yes,
I don't know...
5 is equal to 1. That's actually a very interesting remark.
I wanted to say f of 5 is equal to f of 1, because that would be at least not total mathematical heresy. I don't know the notation, so I was just guessing.
You could say it like this. If f is rotating the cube by 90 degrees in some direction, then doing f 5 times is the same as doing f 1 time.
Because I need it in life. So this is our group. However, I was thinking of... My goodness, that's a fancy looking character. What I was thinking of is this, which is way, way different. Because this is finite. This is actually... I don't want to say... No, it's not 6, because you can flip it. Not flip it, only... you can...
There's actually... in total, there's 24 possible rotations that you can get with this.
Yeah, so this is 24. This is infinity. I don't know notation, and I... You know what? Normally, I feel confident just putting arrows everywhere, because normally, you know, arrows aren't part of the notation, but mathematics has other things to say.
You'd write it like this, I guess. So G is your group, or just any set, and between vertical bars, it means the number of things in it.
Yeah, so that's kind of like the magnitude. So
yeah,
I don't know if that's where it stems from, but
for sets we don't say magnitude. We say cardinality.
That's what cardinality is.
That's the number of things in a set.
Oh my!
That's what cardinality is.
Goodness.
Cardinality is that's I mean, when there's a finite number of elements, cardinality is very concrete and very understandable. When there's an infinite number of things, it's harder to understand. Disclaimer.
I understand.
But yes, that's what cardinality is. Cardinality is more or less a good notion that we've developed of what the number of things in a set is.
I understand groups now. As in, not like mathematics. I get what they are. That's my bar, honestly.
Right.
Now all I need to do is go through Lie groups, which will be fun. But to be fair, I won't need to go in depth. This honestly helps a lot because it makes sense to me right now how quarks were invented. That makes sense. That does make a lot of sense as like a combination of. Honestly, I had no idea that groups were of combinations. I mean, not combinations, operations. Was it the asterisk there, the star?
Yeah. Well, basically, a group is a set with a way to combine its elements that has some properties, and what it's meant to be, like when we actually use groups in math or in physics, is it's meant to represent the symmetries of an object. That's the basic gist of it.
Thing is, though, in this case you say symmetries, but that's mathematical symmetries, as in like it's gonna have some mathematical definition that's not quite what my goldfish brain thinks of when it thinks of symmetries, is it? Symmetry. I mean, so symmetry would be basically when shapes. It's not exact definition. I'm not trying to do an exact definition. So symmetry would be basically when the shape looks the same way at the end.
Yeah, I see what you mean. And basically, the thing you have to understand to switch from your point of view to the point of view that we have in math is that saying that the shape looks the same in two ways is saying that if you take the shape and you try to move it so it goes on the... Basically, if you got like a drawing that's... If you take your face, because you're extremely beautiful and you have a very symmetrical face, I know it.
Chisel jaw, yeah.
The axis of symmetry, basically, if you draw a vertical line and you try to fold the picture of your face on itself, it's going to line up perfectly.
Oh, and basically, if we rotate the cube 90 degrees forward,
think of the folding as being the
symmetry. I have a phenomenal visualization for it, actually. I do have a phenomenal visualization. Because I have Blender, and I keep forgetting I have Blender. So basically, like, if I have a cube, if I rotate this cube 90 degrees forward, and if I then render an image, this cube is going to... Well, unless my Blender crashes, this cube... If I render it in cycles and give them like different aggressive materials like red and green or whatever, this cube is going to be symmetric to the first one because they overlap. Perfect overlap. Okay.
That's the thing.
That makes... Okay, now it's why its symmetry also kind of makes sense.
That's the thing, that you notice that the shapes look the same way when you look at it from different angles, and basically the point of view we have to make a group out of it is that we think of the operation, we think of the rotation behind it.
You know what this reminds me? So we can do
one after the other. That's the very important part.
You know what this reminds me of? With this whole rotating cube? It reminds me of an explanation Flame has given me, and this is just further proof that I have mathematicians
tend to like group theory because it helps them for like crystallography, I think.
Yeah. I mean, obviously in chemistry, but the thing is, this just solidifies my view that mathematicians are actually to blame for putting spin in particles. So I'm gonna blame you all for now. That's because if you actually switch to a different board, the chemistry board, there's actually first drawing there. It was this. So basically, a cube has a spin of 4 because you need to spin it 4 times to get it back to its original position. Or rather, you can spin it 4 times. So it has a spin of 4. Rectangle has a spin of 2 because you can spin it twice before it gets back to its original position. Of course, that's spins that keep the symmetry on each step. This shape has a spin of 1, and electrons have a spin of half. So we can't even picture them. And from like a mathematical point of view, this seems just like the symmetry of the cube. Except you just had to extend it to fractions because you couldn't help yourself, could you? Next step is always extend to irrationals, then transcendentals, then complex. And then everyone.
In group theory, so the notion of like how many times you have to do something in order to get back to doing nothing, that's called order, the order of an element. And actually, I've never heard of fractional orders, so that's interesting.
But yeah, I mean,
you're right. There's probably someone who has tried and maybe succeeded in generalizing something to rational numbers.
because
They
of
just don't know about
that's
it. They just don't know
that's
about it.
always the next logical step in mathematics.
Yeah.
When you have something that works, try plugging in the fraction and see if it doesn't.
But actually, I'm thinking about it, and
Yeah, it doesn't make sense, does it? I mean, mathematically, it
honestly,
kinda.
I can see that, and we're kind of doing this, and we're doing a version of this. We're going to do a version of this in one of my classes. Basically, we replace the integers. I'm not going to go into too much detail, but basically, we're doing something. I'm doing a course on dynamical systems, so that's basically taking an operation and seeing what happens when you do it like a lot of times, more or less. It's more analysis than algebra.
DS said if the rectangle is 2, shouldn't the square be 1? No, because this tells you how many. Actually, let me draw it right here. It's going to be easier.
Yeah.
This, but a little one because we need to conserve space. We only have one board per topic. Not wide, that's ridiculous.
I mean, you can erase some of the things.
No. Budget cuts, erasing's too expensive. We're not doing that. So basically, if you have a cube, you can rotate it once. Pretend that it's a cube. You can rotate it once and you have the same symmetry. I'm gonna sound so smart now when I explain things. Speaking of symmetries and whatnot, I'm gonna sound so clever. So we can explain. You can rotate it once and keep the same symmetry, right? And basically, you can repeat this 4 times before it goes back to its original position. The E, if you will. I feel so clever already. For rectangles, you can rotate it once, like this. You have one rotation before this when the symmetry is the same, and then you can only rotate it back again before you get back to the original position. So each rotation has to keep the symmetry. And then if you have a complex shape, something like, I don't know, something really complex, there we go, you need a full rotation to have the same. I don't even know how to draw the dotted line. The point is you have a complex shape, you have to rotate it fully. And the thing is, this is Flame's. Flame explained to me. I didn't even get it because it's electron spin. Of course, I didn't. The thing is, apparently, the mathematics of the electron are like the same thing, except electron has 1/2. So basically, hold on. This means I'm trying to point towards what 1/2 would mean. So basically, you can rotate it half a time. You have to rotate it twice to get into the original position. So you have to rotate it by 700, not quite, because it's not going to be in terms of degrees, it's going to be complex freaking subatomic rotation. So you have to rotate it, in quotes, by 720 degrees in order to get back to the original orientation of the electron. DS, if it doesn't make sense, then that means you understand, because it just doesn't make sense. It's spin. It's awful. But I do like it. Mathematics do be fun. It's just that when your explanations begin to look like Principium Mathematica, which I keep mispronouncing, then that's when let's just say I'm getting a bit spooked.
Well, that's because I'm on a whiteboard. On a whiteboard and on Discord, and I don't really want to. I don't want to write words because it takes.
No. To be fair,
if you're going an actual math lecture, or if you read like math upper math textbooks, there's a lot of words.
Oh, I know. When I was doing
because
research,
we think in words, we're
yeah,
not robots.
when I was
And
doing
most of us-
research for, oh, actually, yeah, this is something you could have helped me if, oh my goodness, when I was doing research for the How Math Becomes Difficult video,
Yeah.
I knew what Fourier transforms were used for, but I didn't know how they worked, or why they worked, rather. So in order to that research, I went to the Fourier series, and the thing is, it's actually surprisingly difficult to find an explanation for how the Fourier series works in an intuitive way. And one of the papers I found was, I think, from 20 years ago or something. I think it was an MIT paper. Or not paper, lecture notes. I don't know exactly what. It looked like a paper. It was very similar to a paper, except it was like one continuous chapter. And it was just mostly words, except every half a page you got an equation. Dense, solid blocks with small font, no images, no graphics, no nothing whatsoever, not even a function graph to help break it down a bit. No, you want a function, imagine it in your head. You got a brain. It was a painful read and it didn't clear up anything. So, I mean, I know because...
That's because you're probably not the target audience, actually.
Yeah.
I mean, basically, like, when I tried to explain briefly the thing with how we can order numbers 1 through 5. If I spoke to someone who had a little bit of background in math, I would have defined it like this. I would have said, take bijections from 1, 2, 3, 5 to 1, 2, 3, 5 and put the composition on it, and it's a group. Like, the thing is that
makes sense.
It's what you explain in your video. Basically, you need a background and more background and more background, and as you read something more advanced, it assumes even more background. So it's really hard to get into
but that's the really annoying bit, is that there's no sidestepping this issue. This is not something I really want to make that clear, and I really try to make that clear in videos as much as I can, that we shouldn't blame like professors and scientists for making things really difficult, because if they didn't want to make things difficult, then a paper that's like 60 pages long would have to be 1,000 pages long at the very least. And so
that's because you're not really meant to read papers. But I mean, for instance, when people do pop physics, they explain that relativity is kind of like, space is curved. It's kind of like if you put a heavy object in your bed, and so stuff falls. I mean, that's not hardcore science, but it's an explanation of the intuition behind
the analogy.
And it's possible to do that for math. For instance, like, you brought up knot theory, and even though knot theory is a very advanced topic,
that's what I actually love so much about Free Blue and Brown, because the thing is, Free Blue and Brown somehow finds a way. It is baffling to me. Free Blue and Brown somehow finds a way to, instead of making analogies, apply mathematics, which is incredible. Whenever you do analogies for physics, you will always fail. It will always be inaccurate in some way. So the relativity example is great, because when you put a heavy object on your bed, it's just curving the mattress. But when it comes to relativity, gravity is more like the extension of acceleration. Acceleration is the, I would argue, more important bit of it. And that mattress analogy doesn't really account for acceleration. If you have an object accelerating on the mattress is not going to care. And so analogies always fall flat, but Free Blue and Brown somehow finds it. I need to tap into my inner Free Blue and Brown for math videos, because Free Blue and Brown always finds a way to, I don't know, make a video about Fourier transforms where he explains how you can create curves with a Fourier transform with just rotating objects, or I don't know, stuff like this.
Yeah, I've heard of that. I mean, if I had more time and like I was actually dedicated, and I mean, if I had more time and I was less lazy, I'd probably like learn manning and try to make my own math videos. But
the thing is, that's why I respect Free Blue and Brown so much, because there are a lot of content creators whom videos I see every now and then. I'm like, I could do that if I had time. Free Blue and Brown animates in Manim, which is an engine he made. So, and that's so impressive to me. Because there are a lot of other mathematics
the thing
channels
is
which...
that 3 Brown is a full-time science communicator, basically.
Yeah, that which is a huge...
And that's his job. I absolutely do not see myself having the time to like make good videos with manning and doing research.
I'm there with you. I'm not a full-time YouTuber. I am right. I'm not a full-time YouTuber yet. I'm getting close. This is just
that's why I think like if you made an explainer on groups using Blender, you've got so much potential to like represent you've got so much with Blender. You can represent extremely well what groups are. Basically, you can rotate. I mean, you rotated a cube in Blender. That's like the most fancy format.
In Blender, you have a cube. That's basically 90% of the effort there already. The thing is, I first need to do a video on linear algebra, because not having a video on linear algebra in Blender, I did kind of make the you can do physics in 7 dimensions, which is kind of it, but that had a different goal in mind. Not having a video about linear algebra in Blender is a crime. It's to say that it's trivial to make, it's an understatement. It's literally what you do when you animate. Like, when you animate with geometry nodes, you're literally doing linear algebra to make animations. You have the mathematics in there. So, my matrices geometry nodes really did use... I did just implement matrices in Blender. Because I'm pretty sure you can do matrix transforms, but I had to break it down, so... find out.
But I mean, basically, well, linear algebra is like the really well understood area of math.
Yeah, because
I mean, calculus is basically what if I zoom in on my function and suddenly it becomes linear algebra? Actually, when you're studying groups, since groups are pretty hard, a whole topic exists. It's called representation theory. It's basically studying groups or other stuff with linear algebra. I actually did my whole bachelor thesis on something in representation theory, but basically...
Representation theory, wait.
I'm trying to explain it.
Wait, representation theory?
It's basically trying to understand groups better by doing linear algebra.
I mean, I know it's so... I know you said it, but I just am having hard... So basically...
Like, I mean, basically you can build groups out of matrices. Like with matrix multiplication as the operation.
Wait, so is that really what it's... That sounds like just professional visualizator, I don't know what to call it. Representation. So like a mathematical theory of how to represent stuff. Because with linear algebra...
It's called representation theory because you're basically taking like a group and you're transforming it into matrices, which are something we understand better because we understand linear algebra really well. And so it usually solves problem really good. There are some examples of some... There's a theorem by Burnside. Burnside was an English group theorist who did a lot of stuff. Basically, he proved a theorem. He said, if the cardinal of a group's... if the cardinality of a group, of a finite group, looks like this, then it's solvable. And he proved it using representation theory, and actually we didn't find a proof that didn't use linear algebra in it for a really long time. Like, it makes things easier, that's the point.
Makes sense.
We call it representation because you're kind of representing a group using matrices. I guess that's the thing of it. But I wouldn't call it like I wouldn't say it's very geometrical. It's not really geometric.
So it's basically the worst part of matrix. Got it. Cool. Neat.
No, it's very algebraic. Actually, when I think of I'm an algebraist, more or less. I like a bit of geometric stuff, but I'm much more comfortable working with abstract things. Representation theory is very, very algebraic.
The thing is, I mean, I get that, I get liking to work with abstract things, but, you know, I still think that memorizing how to do a matrix multiplication is a crime. No one should have to memorize it.
You know where it comes from.
Yeah, but the thing is, there's so many people who memorize it, and it's honestly sad.
But it's because I mean, in my biased pure math guy opinion, we shouldn't teach matrices before we teach like abstract linear algebra. At least to people who want to do actual math. Because it's really sad that we just say, oh, it's tables of numbers, and we multiply it in the weird way because just do.
Also, I feel like actually no, never mind. Where does the charge of the quark come from? Because you add electron to up quark and it makes down quark, but where does it get the original charge from? You can add electrons charge by the weak force. You mean where do the original charge of the quark comes from? It's an elementary particle. You won't. There's nothing smaller than that. Quarks just have charge. Half quark makes it down quark. Yeah, so I'm assuming that's weak interaction. Why do gluons make a force against acceleration? Because it's fundamental. There is no explanation for fundamental forces in elementary particles, Randy. You won't find any. They're the basis, unfortunately. Or fortunately. That Rubik's Cube was the topic. I have 6 cubes on my desk right now. No, it's a group. I wish it was Rubik's Cube.
Well, no, but Rubik's Cubes can be studied using
I can,
theory, actually.
I can see where the group theory would come in, because it's basically like the cube we used,
I have a lot of cubes on my desk right now. I mean, I have one Rubik's Cube, I have another, I have a 4x4 I don't know how to solve, I've got a tetrahedron, Pyraminx, I've got a dodecahedron, Megaminx, I've got a Rubik's Egg, which is somehow harder than a standard Rubik's Cube because it doesn't have any colors. It's pretty great. Actually, Rubik's Cubes are a very good way to explain I mean, I don't know the math behind it. I probably should learn it sometime.
I feel like solving methods for Rubik's Cubes would be
Rubik's Cube. Studying the mathematics of Rubik's Cubes is an actual, really cool application of group theory.
Yeah, I feel like you could mathematically like design the solving method using group theory. If you have a desired.
Yeah. You can also like I mean, basically people have figured out I mean, groups are like extremely adapted to talking about Rubik's Cube, basically. For instance, you can for instance, using group theory, you can more or less figure out exactly what all the possible moves you can do on a Rubik's Cube, and so you can calculate the precise number of states that your cube may be in. That's a cool application.
Makes sense.
It's not easy, but you can.
I'm assuming.
That's not something. That's not. I should learn this at some point. Like, it's really cool and it helps with math communication. I should learn this.
You know what? I feel like that might be it for me today. I'm having a headache.
I should also go to sleep.
Yeah, that's also
math
true.
To do tomorrow. Unfortunately, I don't have classes in the morning tomorrow, so I'll be fine.
Oh damn! I got worried for a second because you are in Europe. This should be asleep at this point.
I'm in the same time zone as you, if I'm not mistaken.
Yeah,
it's
which
where you live.
Yeah, so you should really be sleeping, especially considering you have, you know.
Don't worry, my sleep schedule at the moment is a bit fucked. It's if I had classes like in the early morning tomorrow, I wouldn't have come on stream. Like
That's fair, I suppose. Actually, that's a really long time.
I'm putting my studies first.
How dare you! How dare you put your studies before joining in on a random live stream? Oh, I am no, that's it. Over. I'm going.
It's not a random live stream. Like, in my opinion, you've got a lot of potential as a science communicator because you've got a thing that most people that actually know stuff lack, which is you know how to do stuff in Blender. No, really, like I mean, when you talked about the paper that you read that didn't have any graphs in it, it's probably because drawing graphs in LaTeX is not really fun. Like, it takes a lot of time, and so
I would say
most people don't bother.
I would say it's a nice relationship that's so parasitic that it's actually symbiotic. So basically, you have scientists who do all the actual heavy lifting in science, and then you have science communicators who just siphon away all of that hard work and research, for money. And but then because you need to communicate in a nice way for people to actually care, this actually ends up with people caring about the underlying science and then reading forward. It's a relation that's so parasitic that it actually works out kind of.
But that's really true. Like, I mean, I would have probably been less interested in math if I didn't watch math videos on YouTube when I was little.
Yeah. It's just so
I mean, they were in French, so it wasn't Hugh. Maybe
but
because it was like 10 years ago, also. But
yeah,
doesn't
but it's totally not a cult. It's totally not like I'm not like a guy
We're
who's
not a
in
cult.
charge. Yeah, it's not a cult. I'm not the guy in charge of indoctrinating people. No, it's not a cult.
We are not a cult.
We are not a cult. We just do science. We have certain things which we hold as true, and we do believe normal things, scientific
I'd
things.
say that there is one thing that science communication kind of fails at, but I can see it being solved. Is that for me the really cool thing about math is that I can do it. Like, I can think about stuff and prove theorems and stuff. I mean, I haven't done original research, but I can like more or less do math, and that's not really something that you can transmit with just science communication because it requires actual effort on the listener's part, and most people don't really want to go through the painful process of actually learning stuff to become proficient themselves, and that's fine. That's fine, but like,
The thing is,
it's kind of sad that I can't really show or everyone what it feels like to have this aha moment.
I mean, the thing is,
And then finally understand something.
really often in a lot of it, I have seen people like, oh, let's make a pause and let's think about the answer before I actually reveal it. And really often also,
Yeah,
I've seen a lot of
in
people.
videos, that's really common, and I really hope that people actually listen to when math communicators say this because it's important.
Yeah, I mean, the thing is also another thing is in a lot of science videos in general, right? Like the creators clearly saw that the let's pause for a second and think approach didn't work, and a lot of them are forcing it. So basically, either ending a video with a question that they just don't reveal the answer to. If you want the question, like an extremely curious question, or if you want the answer, you gotta figure it out yourself. Or Robert Miles.
But the thing is that even if people actually try to pause the video and think about it themselves, I mean, doing math is hard, and that's why when you get into when you're doing a math degree, at first they more or less teach you how to think, not in a way like we're not in 1984 way, but basically like how to speak math, and that's important because math is really not that intuitive. I mean, like, it's knowing how to actually do a correct proof and write it out and be sure that it's correct and stuff is very hard, and that's why like self-studying math is also very hard at the beginning, and that's why most people just learn with teachers. That's You need someone who's knows stuff to like give you feedback on what you're doing, and that's really not possible with just math videos, and that's kind of sad, but
Yeah, but that's what live streams are for.
What do you say?
That's what live streams are for. Exactly. Yeah. Hey, Reblax, why do gluons make a force against? That's mathematician.
That's not my
math. That's Remco. Remco's deal with is physics, especially quantum physics and relativity.
Ask Remco or Scarlett about this.
Actually, Reblax, you know what? I am curious. Why is the Pauli exclusion principle actually in place? Why can't electrons have the same quantum numbers?
I mean, come on, electrons need to be original in life. They're just not going.
They're not a bunch of poses.
Have the same numbers. Like that's just boring. Really. And chemistry should be fun.
Anyway, I am having such a headache. I feel like I'm dying. I'm dying past couple of days. But daily means daily. No excuses. Just because I'm dying doesn't mean I'm gonna stop streaming. Boy, I'm really sacrificing my health for for YouTube. That's great. That's gonna be, boy, when I die, if there's gonna be some sort of, you know, like a question or whatever, you know, someone questioning my life choices, that's gonna be one for the books. Anyhow, I'm thinking I'm gonna go now.
Yeah, I'm going to go too.
Yeah, it is 3 a.m. after all. So I suppose. Oh, thank you so much, Reblex, for being on stream and explaining groups too. That's convenient.
No problem. I mean, a better explanation would require like many hours long lecture, so I guess that's the best I can do.
I understand. It's fine. I get it. I'm like, as I mentioned, I knew nothing about the group, so that still helps.
If I wanted to explain it better, I should probably make my own videos.
Yeah. Oh well. Anyhow, thank you.
Actually, I will say this before the stream ends.
Yep.
Because there is actually a really good video about groups that I saw. It was for the Summer of Math exposition. It was made for it. It was, what's it called again? Oh yeah, just need to find it. And I guess yeah, it's called Researchers Use Group Theory to Speed Up Algorithms, and it's half an hour long, so it's not a short video, but I think it gets across the main concepts pretty well.
My videos are half an hour long, so.
So I guess I guess I'll send it to you like on in the chat of the live voice channel, so maybe you can look at it for when you're feeling less like you're dying.
I can look at it while I'm dying too.
I think it's pretty good, and the visuals are really neat, so maybe
I'm feeling a bit jealous, but okay.
Oh, it's not made using Blender. I think it's made using Manim.
That's the same person that made Fast Inverse Square Root video.
Yeah, it is.
I saw that video.
Let me begin my introduction.
The guy is coming at it from, I guess, a more computer science focused perspective, but it's still, as an introduction to groups, I still think it's really good.
I don't get
it. It even finishes by proving like a really beautiful theorem. So
I mean,
that's always nice.
I'll be honest. I don't really get the difference between computer science and mathematics. I feel like computer science.
Computer scientists are mathematicians from the computer science department.
No, I see. I mean, to me, it always seemed like computer science is just like mathematics, except with additional rules that you have like memory and whatnot.
Really. I mean, honestly, computer science, theoretical computer science is mathematics, but it just doesn't really study the same objects as traditional mathematics do. Like mathematicians will be interested in functions, derivatives, geometric things.
You can't have infinites in computer science, for example. That's a pretty big
spaces. One. Computer scientists will be interested in data structures, algorithms, time complexity, space complexity, and stuff. But in the end, it's I think it's really similar.
It's just mathematics.
I mean, like yeah, it's I've heard many people say that computer scientists are mathematicians in a different department. So I mean, I think you're right to think that.
Always seemed like I'm sorry, I just having trouble thinking. Yeah, it always seemed that way. Me. Or maybe that's just me trying to generalize everything as much as possible. There are only two fields of science, physics and mathematics. Everything else is a myth. Everything else is just someone feeling quirky and being like, "Oh no, I'm totally not a physicist. I'm a chemist. I totally study different things." Absolutely roasting chemist, roasting flame behind his back. Well, that'll be it.
I think my job here is done. I've tried to explain groups. I've sent a better explanation by someone else.
It still helped. It's still nice to get at least the basics. Anyway, I am gonna go because I am.
My opinion is that you should try to get stuff explained to you by as many different people as possible, so you can maybe find a perspective that best suits you and just.
That is true. That does help. That does help a lot.
Right. I guess. Well, bye, Naked. Bye, everyone on the stream.
Bye, Reblex. Bye. Have a good one, and everyone too. I suppose. For now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye.